Alright, welcome to Academic Graduate Class. Today we are going to be treating mathematical induction, and here with me we have a question that says prove 7 raised to the power n minus 2n is divisible by 5 for all positive integers. So this is the question. They said that we should prove that 7 raised to the power n minus 2 raised to the power n is divisible by 5 for all positive integers. So let's say, if I say that something is divisible by 5, it simply means that it has to be equal to, let's say, 5 of something. For example, we know that 2 times 0 is equals to 0. So we can't divide anything by 0. So if something is able to divide another thing, it simply means that it has to be a multiple. So that means I can say let this be equals to 5m in that case. So I will now apply the principles of induction. So remember, they said we should prove that this is divisible by 5. That is, they're trying to tell us to prove that this can be the same thing as saying. So whenever you see this kind of question, what you just need to do, then you apply your induction steps. You know that the first step is what we call the basic step, which is the same thing as saying this thing that I'm giving, 7 raised to the power n. In this case, we will say when p of n equals to 1. So that means that anywhere I see n, I'll put 1. We call this the basic steps. Minus 2 raised to the power 1 equals to 5m. So 7 raised to the power 1 is 7. Minus 2 raised to the power 1 is 2. 7 minus 2 is 5 equals to 5m. So we can see that we can divide both sides by 5. Divide both sides by 5. So m is equals to 1. Which means that this is divisible by 5. So we've proved it for the first step. So whenever you are treating induction, they tell you prove that something is divisible by. The first step is whatever they say is divisible by, equate it to some unknown variables. Then put that device that they are talking about there. So let's go to the second step. So in the second step, we do the induction hypothesis. And this induction hypothesis is where we assume that, or we say when p of n is equals to k in this hypothesis. So we assume here. So that's 7 raised to the power n minus 2 raised to the power n. Remember I said always equate it to some unknown variable. You can use z or whatever. So anywhere I see n here, I replace it with k. This is going to be 7 raised to the power k minus 2 raised to the power k is equals to 5m. So once I know this, for this stage, which is assumption stage, or you call it the induction hypothesis step, the second step, the induction hypothesis. For this step, what you simply do is just assume. So we assume it to be true. So, but in this case, notice that I have 7 raised to the power k, I have minus 2 raised to the power k. So we just assume it to be true. We assume it to be true in this second stage. Then in the next stage, which is trying to make when p of n is now equals to k plus 1. So this is now what we call the induction stage, or we say in this stage we are to prove. So I normally call it, the first step is basic step, the second step hypothesis, induction hypothesis, or you say it's the assumption step, then this one is the induction step. So what I'm going to do here is, remember, P of n now, anywhere I see n here, I replace it with k. So I will have k plus 1. So in this place, I'll have 7 raised to power. Let me get marker. Okay, so I'll have in this place, I have 7, and the n now will be replaced with k plus 1 minus 2 raised to power k plus 1, all is equals to 5m. So you know that we have two types of induction. In as much as we know we have induction of sequence and series, inequalities, raised to power, and the rest. But you just need to know that induction is always talking about is a theory or a technique when you are proving left hand side and right hand side is equal, or when you are proving that what you are given can be divided. So in this case, when you are proving that what you are given can be divided, what you do is simply, unlike the left and right hand side where I told you, always use what you have for P of k, then add it for what you have for k plus 1. That is the next step to get what you have this side. But in this case, what you are going to be doing is you will check right here as I'm saying this now. 7k plus 1, this thing that I have here, is the same thing as saying 7k times 7 minus 2k here is the same thing as saying 2k plus 1 is the same thing as saying 2k times 2 is equals to 5m. Alright, I want to have space, so I'll just leave this. I'll carry this thing that I have for P of k, so you'll be seeing it. So remember P of k, everything about when n is equals to k gave me 7k minus 2 raised to power k is equals to 5m. So we are not touching this, we are just leaving it. So I want to continue this part here so that we will see something. So now see that if I look here, if I look right here, this 7k, this thing that I have here is also found here, and what I have here is also found here. So I can choose to go back to this equation, make this subject of the formula, or make this one subject of the formula for when P of n equals to k. So I will simply say 7 raised to power k is equals to 5m plus 2 raised to power k. So why did I do this? It simply means that for P of k, when you are trying to do division, when n is k, what you're going to be doing is, anywhere you see this 7 now, remember if you did your own, this to be the subject formula, no problem. I just chose this. So anywhere I see 7 raised to power k inside P of k plus 1, I'll replace it with this value. So that is the concept. Once I see any value here, I replace it with this. Now let's check something first of all. I have 7 raised to power k. Yeah? Then I have times 7. Then I have minus 2k. Then I have times 2. I can choose to say let's collect like terms, or before I collect like terms, let me replace this. I can choose to say let me replace 7 raised to power k with this. So right here, this value, everything I have here for P of k, I will replace it with this, so that this becomes 5m plus 2 raised to power k. Don't be fast to collect like terms, so you don't make mistake. So times, notice that this is 7 raised, so all times 7, then minus 2 raised to power k times 2, I'm rewriting everything, equals to 5m. Remember that this has done what we want it to do for us. We've used this to replace 7 raised to power k inside here. That is the goal. So whenever it's division, the minute you get to P of k, make any one of them subject of the formula. Once you do it for k of k plus 1, you will use that value and substitute. Then you try to see if it can now be divided by 5. So let me just clean this so I have more space. Then we are here. So at this junction, remember that what I have here is the same thing, just that I replace 7 raised to power k. So let's check. Can anything be done here? Can anything be done? Okay, let's check. I can say let this is minus. I can say let everything here cross equality sign. So it now becomes 5m should be plus 2 raised to power k. Then I have 7 into 5m. So let's say 7 times 5m is 35m. 7 times 2k is plus 14 raised to power k. 14 raised to power k. But I will not be fast to do that because I see that this side I also have 2 raised to power k. So I don't want to do that. I just leave it as 7 dots. But for those of you that don't like wide imagination, let me just write it. This becomes 14 raised to power k. Okay. Now notice that at this junction I can say, what am I trying to make the subject formula here? I can say at this junction, let this one as well cross equality sign. I can say let this cross equality sign. So if this happens to cross equality sign, I will now have, okay, or I can say collect like terms. So I will have 35m minus 5m equals to 2 raised to power k minus 14 raised to power k. So remember, we have no use for this because we used it to replace something. So I will now have 30m is equals to 2 raised to power k minus 14 raised to power k. You can see that this is the same thing as saying 12 raised to power k. So you can see that if I come over here, at the point where I have this, I have 30m, I have 12 raised to power k. So you can see that this is the same thing as saying this is the same thing as saying divide both sides by 30 by 30. This will cancel this. So m is equals to 12 raised to power k over 30. And let's check something. You see that I have this. 5 can go through here. 5 can go through here. Okay, 5 can't go here, but 5 can go here. Which means that we are not supposed to have gotten to this extent. So I think at the point where we're supposed to get is this point. This point that we have this. This point now. Because remember, we are trying to prove that this can be divided by 5. So we use that concept. So applying the principle, we are simply going to have let's say everything here is equals to 5m. Okay, that 5m, this 5m, at the point where we have this 5m, this is where we're supposed to have stopped this, so that I now have, so I have equals to 5. So I have this now, and I can see that if I say divide both sides, this is the same thing as saying 35m plus 7 or 14 raised to power k minus 2 raised to power k times 2 is equals to 5m. And you can see very well that what I have here, I can say divide both sides by 5. Yes. So this is what I will have. So if I do this, m now is equals to what I have here. But remember that the values I have here is the values of k plus 1. The values I have here is the values of k plus 1. So we've been able to prove that this can be divided by 5. But since the values are values of k plus 1, we need to simply make room to say that this everything here is simply equals to 5n. So everything is simply equals to 5n. So if I know that that accounts for what I have here. So let's check something. Where I have 2k times 2k, 2k times 2k, this should give me around 4 raised to power k minus 14 raised to power k plus 35n. You can see that if I do this now, this will be 14 minus 4, which is going to be 10 raised to power k plus 35n is equals to 5n. So if you check it now, you see that everything here can very well be divided by 5. Because if I say divide this by 5, divide this by 5, 5 go here, you have 7n. 5 go here, you have plus 2 raised to power k. So which means that everything we have down here is the same thing as saying 5 into this equals to 5n. So hence we've proved it. Proved. So we've been able to prove it. Let's refill the marker. Alright, so for question 2, let's look at the question 2. The question 2 says, prove 6 raised to power n plus 4 is divisible by 5. Should it be? Yes, by 5 for all positive integers n. But in this, the English is not my problem. So what I'm checking is simply what they have given me. They said that I should prove that 6 raised to power n plus 4 is divisible by 5 for all positive integers. So that means that this can be 5. Then let's say this variable is a positive integer. So it can be any integer. But notice it cannot be minus because they did not say minus but positive integers. So 6 raised to power n. Now, I will account for this by saying for p of 1, let's check. 6 raised to power 1 plus 4 is going to be 10 equals to 5. So m divided by 5 divided by 5. So that means that for p of n equals to 1, it is true. So let's check for p of k. So we say when n equals to k. So when n equals to k, or we say when p of n, that is the proposition n, is equals to k, we now have 6 raised to power k plus 4 is equals to 5m. I'm using m. I'm used to the habit of using m. So, but you need to know this since they said it's divided by. So once I've gotten this is for my k. So notice that I have something unusual here, which is carrying raised to power k. I need to make it subject of the formula. It's a habit. You need to make something subject of the formula because you need to get into the habit or into the knowledge of knowing that whatever you get for k here, that's what you substitute. When you see k plus 1, you try to single out the part that looks like k there. Substitute the value of k inside it. But that's why most people get confused. They carry this knowledge even to when it has to do with left hand side and right hand side. For left hand side and right hand side, you simply do p of k plus 1. But here, you simply substitute k inside k plus 1. That is for the k that is inside k plus 1. So that means when p of n is equals to k plus 1, I will have 6 raised to power k plus 1. Remember that what we are given is 6 raised to power n plus 4. They're asking us to prove that it's divisible by 5, so I put equals to 5m. So this is going to be the same thing as saying equals to 5m. So let's say I made this subject of the formula, this 6 raised to power k. You see that it could have given me 6 raised to power k is equals to 5m minus 4. That's what I could have gotten. See what I mean? So I could have gotten 6 raised to power k equals to 5m minus 4. So when p of n, or when n equals to k plus 1, I have 6 raised to power k plus 1 plus 4 equals to 5m. And this is the same thing as saying 6 raised to power k times 6 plus 4 equals to 5m. So just come here. The value of 6 raised to power k, which is 5m minus 4, substitute it here. So I have 6. So I have 6 raised to power k, substitute. I have 5. Ah, good. I didn't refill these markers and it's misbehaving now. So I have 5m minus 4 all into 6 plus 4 is equals to 5m. Okay. 1 minute. Let me see if I can refill my marker. So this is going to give me 6 times 5m. 6 times 5 is 30m. Wonderful. 30m. Village people. 30m minus 24 plus 4 equals to 5m. So you can see that minus 24 plus 4 is minus 20. 30m equals to 5m. So 30m minus 20 equals to 5m. So this is going to be the same thing as saying divide both sides by 5. 30m minus 20 equals to 5m. Divided by 5. Divided by 5. 5 here. 6 minus 20. 6m equals to m. So which means that we've proved it. 5 times 6 is 30 times 10. 5 here is 10. So 5 go into 20. 5 go into 20 is going to give me, why are you saying yes? It's going to give me 10. Then 5 going to m is going to give me 5m. Hence, we've proved it. Proved. What am I saying? I'm so trying to rush this. I said 5 times 10 instead of 5 times 4. So bear with me. Bear with me. So this is going to be, even I have a special trick for anything that has to do with multiplication of 5. Whenever you have a value that is 5, being multiplied by 5, simply reduce it by 2. Then add 0. Just like 5 times 800. I know that 800, half of 800 is 400, Shebi? Then add 0 to it. So 5 times 800 should be 4,000. So there you have it. That's by the way. So we've been able to prove this. Proved. Which means that the value 6 raised to power n minus plus 6 raised to power n plus 4 is divisible by 5. Alright, so let's solve the last one. To solve this last one, I really need to review my math. So